Sometimes what we have is we have a composite object that's really, two individual objects that are kind of pressed together. So it's not one on top of each other like the last example. And in this case, when we have two that are joined, we have to separate them into two different individual objects. We can draw a line in places in order to separate. We've separated this one into a rectangular prism base right here and a triangular prism top right here by drawing that line across. And we know that since this is the same as this and the same as this and the same as this, and these are all 10, we can go ahead and label those as 10. And that means if it's the distance across the bottom is 10, then the distance across here is 10 as well. We know that the height of this triangle, right angle triangle, the height of that is 12. We know that the depth of this rectangle is 4 because it's given to us. What we don't know is the length of this side right here. Now, fortunately, being a triangular prism, and we know the height of it, and we know that this creates a right angle triangle, then we can use the Pythagorean theorem to find out the unknown side, C. We know that this is C because it's across from the right angle, okay? We can start putting our numbers in. For a squared, we'll use 12 right here. For b squared, we don't need the whole thing all the way across, the whole 10. All we need is half of that, so we only need 5. So this is 5, and this is 5. Okay, this is 12. We can start doing our math. 12 squared is 12 times 12, which is 144. 5 squared is 5 times 5, which is 25. When you add these two together, 144 plus 25 is 169. And don't forget, we have c squared right now. If we want c, to get from c squared to c, we have to square root it. Whatever we do to one side, we do to the other, square root it, and we get c equals 13. We now know that this side is 13, and we have all of our measurements to continue. We can do the rectangular base by calling this the front, by calling that the side. Okay, so the front and back would be 10 by 10, and there's 2 of them, and 10 times 10 is 100, times 2 is 200. The sides are 4 by 10, and there's 2 of those, so 4 times 10 times 2 is 80. The top and bottom, we don't need the top. Don't forget, this is surface area. Surface area is that you can touch. We can't touch the top of this box. So we can't include that as surface area, but we can include the bottom, a 10 by 4 bottom, which is 40. We add these together, we get 320. 200 plus 80 plus 40. So it's 320 for the rectangular base. For the triangular top, the front and back is a 12 height by 10 base. Remember, the front and back is area equals base times height divided by 2. But that's for the front. If there's 2 of them, because we have the front and back, we just cancel these out and do the base times the height. So the base is 10, and the height is 12, and that gives us 120. 12 times 10 is 120. The sides, if you look at the sides are right here. They are 13 by 4, which is 52, and there's 2 of them. There's this side, and then there's that side. So times 2 is 104. The top and bottom, well, we don't need a top here. There is no top to a triangular prism. And we don't need the bottom either because you cannot touch the bottom of this triangular prism. So we don't need that either. Normally I wouldn't write it up. I just wanted to show that we cannot touch the bottom of this, so we would not include it. So we don't have any math to do there. So we can get a total now of 120 plus 104 is 224. Now we have the surface area of the parts we need from the rectangular base. We did not include the top because we can't touch it. The parts we need from the triangular top, we did not include the bottom because you cannot touch it. When you add these together, you get a total surface area for this object. 320 plus 224 is 544 centimeters squared for our total surface area of that object.